Hey everybody, today we'll do another problem, and today we will continue with differential equations, and we will do a new section. It's called solution by substitution on first order of differential equations. And I'm not going to go over the definition too much in this case. It's a very straightforward. It requires a little bit of algebra, not knowledge of algebra to get these problems done. And again, so the definition, I guess, is very important, nowadays, right, with the generation that we're living in. The mothers, right, which are women, mothers, they want to change the definition of the woman they don't want to call a mother, right, because it's already a mother, right? They want to call it birthing people, right? They want to, so with that being said, I have to put that out there because it's kind of one of the things in engineering, though, is like is reality. So electricity is already defined and it's real. So just because you want to call current or voltage a different name, for example, I will not recommend you to call a different name and stick your fingers in a socket, right? In a 480 volts. You can call a different name, but that doesn't change anything in electricity. I will not recommend that. I'm not saying you to do it, but this is about science, right? About reality. But apparently, some people want to be so smart that they want to just redefine things. But anyway, that's another topic. But again, because this is engineering. This is Conservative Engineering Academy. I am a Christian. First, I want to please Jesus before I please anybody else. So therefore, I have to just take a few minutes to explain this, right? But anyway, so the definition of this by substitution is very straightforward. I'm not gonna just explain it. It's kind of very simple process. So let's get started. Let's say, for example, that we have a problem like this, right? So we have x minus y dx plus x dy equals 0, right? So this is a first order differential equation, and as you can see right here that I have two derivatives. I have the derivative with respect to x and the derivative with respect to y, right? So the idea is that we could let y equal to vx, right? So if we let y equal vx, then we can actually do something with that, right? So we can take y equal vx, right? So then we say we take the derivative of this. When we take the derivative of y in this side and v in x in this side, we have to take the derivative with respect to both on this and this, and with respect to the y, right? So we do on the left side we do dy, right? The derivative of y is dy, and then the derivative of u in x. If I take the v, right? If I take the derivative of v, right? Then what I do is I take the derivative of that and I call x, right? X is treated as a constant. And I do dv, right? So x dv, right, is equal to the derivative only with respect to v in this case. Now, I have to use the product rule, right? The product rule tell me the derivative of the first times the second plus the derivative of the second times the first, right? The derivative of the first times the second plus the derivative of the second times the first. So I already took the derivative with respect to v, right? With respect to v. Now I gotta do with respect to x, right? So, and then I do with respect to x, I got a v dx. See that, right? So that is the derivative of this. Now I come over here, and when I see a dy, if I see a dy, I plug this. I plug whatever the dy is equal to, and I get that, and also remember that y is equal to vx, right? So it's going to be x minus y, but remember, what is y, right? So y is vx, right? So y is vx. So I get vx and dx, right? Very important to keep it over there. And that is, and plus that, right? And plus x, right? Times that, right? So x dv plus v dx, right, equal 0. Okay. So now what I can do in this case is simplify this expression. What I can do is factor out whatever I see in common, right? I see an x and an x. I can pull out an x outside, and I get 1 minus v times dx plus x plus x times x dv plus v dx equal 0. Okay, so now that I have that, right, I have to distribute this inside, this dx inside, right? And I get, okay, so, but as you can see right now, I have an x and I have an x over here, right? So I can divide this by x on both sides, divide by x and divide by, right? So that is gone, right? And of course, that is 0. So then I get what? I get 1 minus v dx plus x dv. Yeah, I'm sorry, plus, okay, so x dv plus v dx is equal 0, right? So now, as you can see that I can distribute that dx inside, right? I can distribute that inside, and I can distribute this over here, and I get what? I get dx minus v dx, right? Minus v dx plus x dv, right? Plus x dv plus v dx is equal to 0, right? So now, as you can see right now that this right here, right? This, if I put parentheses around, I mean, I don't have to put parentheses right here, right? Because it's already one piece. I am not multiplying anything with that, so I can get rid of those parentheses, and I can put everything inside one parenthesis, right? So now, as you can see that this and this v dx and v dx, I got opposite signs, which mean that I can add them up, right? When I add two negative, when I add a negative and a positive, I get 0, isn't it? If they are the same. Okay, so now, this is reduced to what? It's reduced to dx. Matter of fact, you know what? Let me just do it. Let me do it right here. So let me bring on this right here. So I have x, I have a dx, sorry. So I have a dx, and then I have that, right? So plus x dv plus x dv, right, is equal to 0, right? So I don't have to put parentheses there, right? So now, as you can see, that this is getting there, right? So dx. Now I can subtract either of this, right? I can subtract this guy and put this in the other side or whatever, right? I can move this to the other side. Let me just subtract dx. Subtract dx, right? So when I subtract that to the other side, I get x dv, x dv equal to negative dx, right? Now, as you can see that I have a dv and also I have a dx, right? But remember that this dx belongs to this x. So I have to separate those. And the way that I can do that is by dividing by x on both sides, right? So I get dv equal to negative dx over x, right? Now look at this. So now the I done is called separation of variables, right? Separation of variables is done now. Now this is basically done. Now integration is easy here, right? So okay, so I integrate this, right? I integrate this. So I integrate that, right? When I integrate that, I get what? I get v, right? I integrate with respect right there. I integrating dv, I get v, right? In this case over here, I get negative ln x plus c1, right? Plus c1. Now I have a negative here, right? I have a negative. What I can do, I don't want this negative in front of this ln, so what I can do is divide by a negative, right? Now I get negative v equal to ln x minus c1, right? Minus c1, right? Now the next step here is the following, right? The next step over here is the following. So now what I need to do is the following. So now what I can do is the following. So in this case, I can actually replace, right? So remember that that y is equal to vx, right? So now I gotta solve for v because I got a v here. So v, if I divide by x on both sides here, I get v, right? So those cancel out, and I get v is equal to y over x. Now, if v now is equal to y over x, I can replace that, right? So I can say that y right here, I replace v is equal to y over x, so I say y over x equal to ln x minus c1. Okay, so now if you can see that now I can actually multiply this across, right? I multiply the x across, cross multiplying, and I get y, negative y, right? Negative y, right? So I want to just basically, yeah, so I multiply this, right? Cross multiply means that I cross multiply this to this and the whole thing, right? So I get ln x, okay. So I get x ln x minus x z1. Okay, so now I need this by itself. I need the xc1 by itself, right? I need somehow to group these things. So now what I can do is move this on this side, and I get negative y minus x ln x minus x z1, right? Actually equals, sorry, it's equals. So this is equal minus xc1, right? Now what I do right here again is divide by negative 1, divide by negative 1 the whole thing, right? So the final answer is going to be, after I divide by negative 1, is going to be y plus x ln x y plus ln x. Okay, so that is equal to xc1. Okay, so that's it. That's the answer for that problem. So it requires a little bit of math, for a simple problem like this. The very basic differential equation requires a little bit of algebra. But the beautiful thing is that it works out at the end. If you kind of keep your work consistently, you will get the right answer at the end. And the answer for that is, the solution is y plus ln x is equal to x times certain constant c1. Right? That's the solution for that problem. I hope you enjoyed this video. If you do, please give me a like. Thank you for watching. On to the next video.